Hello, this is a demonstration of calculating probabilities from relative frequency and frequency tables and the AQA S1 syllabus, and I'm going to use the June 2012 question 4 to demonstrate this. Okay, so as ever, first thing we do is read the question. A survey of 640 properties on an estate was undertaken. Part of the information collected related to the number of bedrooms and the number of toilets in each property. Okay. This information is set out in a table. So here's a table below. Here we go. And as you can see, this is a two-way table. Straightforward GCSE two-way table in which we can see going along the top, so down our columns is the number of toilets, and in the going along for the rows here down the side is the number of bedrooms. So we've got 1 to 5 or more bedrooms and 1 to 4 or more toilets. Note there's no description here about there being any independence, etc., and we'll come back to that, which is why I've chosen this question. Okay, so let's have a look at what the questions are, what else it's going to tell us. Right, a property on the estate is selected at random. Okay, so that's giving us a basis for doing some probability calculations. And if we remember from our GCSE, then relative frequency gives us our probability. Okay, okay? Probability. So what's the question asking us? Find, giving your answers to 3 decimal places, the probability that the property selected at random has. And now we've got 4 different questions. Okay, so let's work our way down the questions, and I'll color code them so we can see what we're doing. Find the probability that the property has exactly 3 bedrooms. Okay, so looking back at our table here, where is the probability that has exactly 3 bedrooms? Exactly 3 bedrooms. Well, here's our row with the number of bedrooms. There's our row with the number of bedrooms is 3, and the total in that row is 194. It's not asked us anything about toilets, so we're just interested in the total, 194, and that is out of the total number of houses, which is 640. Okay, so for the first one, we are going to have 194 out of 640. That relative frequency gives us our probability, which to 3 decimal places is 0.303, and that's to 3dp. Okay. Second question, let's go and do some blue. The house has at least 2 toilets. So let's go back to the table. Where's our row of number of toilets? Well, 2 is this column, second column here, and there's 172 houses with 2 toilets, but it says at least 2, so it can also include 3, and that's 256 houses, and 4, that's 135 houses. And again, we're looking at our total number of houses, so that's 640. So just writing that out here, 172 plus 256 plus 135 over 640 is our relative frequency. That's going to give us our probability, and that equates to, adding that up, that's 563 over 640, which equals to 3 decimal places 0.888 to 3 decimal places, because the answer is actually 0.8796, but we're rounding to 3 decimal places. Okay, Third one, exactly 3 bedrooms and at least 2 toilets. Okay, so we've got a combination here in our table. So we want exactly 3 bedrooms, so that brought us back to there. And here again, we're interested in at least 2 toilets, but we're only now interested in this row with 3 to the houses that fit this criteria. So looking here, the 72 houses have got 3 bedrooms and 2 toilets, so they fit. Next one along is 3 bedrooms and 3 toilets. There's 99 houses with that. And finally, there's 16 houses with 3 bedrooms and 4 or more toilets. Yeah, so we're going to add those up as we did before. So we're going to have our 72 plus 96 plus 16 over 640 houses again, because we're interested in all 640 houses. So that's 187 out of 640 houses, and that relative frequency gives us our probability. So that's 0.292 to 3 decimal places. There we go. So that made life fairly easy. That wasn't particularly difficult to do, as long as we recognise the fact that relative frequency is the same as probability. That's the only thing we need to know in advance. Okay, finally, let's have a look at this, and we'll do this in yellow. 4. At most 3 bedrooms, given that it has exactly 2 toilets. Now, important thing, given that has exactly 2 toilets, because they're saying we're not interested in all the houses anymore, we're only interested in the houses that have exactly 2 toilets. So let's have a look, and that is a column here, so we're only interested now in this column, yeah, for our relative frequency for this calculation. Okay, and it asked us to look for the houses where there are at most 3 bedrooms. So which houses are they? Looking at the bedrooms, firstly you can have 1 bedroom, so there's 14 houses of that. 2 bedrooms is 67 houses with that, and 3 bedrooms, that's the at most, is 72 houses with that number of bedrooms. So taking that down, we have, and writing those numbers down, so we have 14 houses with 1 bedroom, 67 houses with 2 bedrooms, and 72 houses with 3 bedrooms. I think it's better, excuse me, I'm going to write this in black so we can see it. 14 houses with 1 bedroom, 67 with 2, 72 with 3, and that's out of, we're only interested now in the 172 houses with 2 bedrooms, sorry, with 2 toilets. Yeah, so so that's going to be out of 172, so that is 153 houses out of 172. That's a relative frequency, gives us a probability which equals 0.890 to 3 dp. It is actually something like 0.8895, but that's going to round to 0.890 to 3 decimal places. So that part of the question was pretty straightforward, as long as we keep marking the areas of the table that we're interested in, and we understand that the relative frequency, the so many out of so many, is the probability that we're interested in. Okay, so that's the first part of the question. Okay, the second part of the question, B. So read, use relevant answers from part A to show that the number of toilets is not independent of the number of bedrooms. Okay, so we need to understand the idea of 2 events and therefore their outcomes being independent. So if we have 2 events and outcomes X and Y, and they are independent, that the probability of x and y occurring equals, because they are independent, it's just the probability of x occurring times the probability of y occurring, because there's nothing linking them together. Okay, so there's our concept. All right. Obviously we can write it the other way around, therefore that it'll be the same thing. But let's have a quick look at what we've got from earlier, that word that they may be referring to here in part A. So what did they ask us to do? Let's have a look at number 3. They asked us in number 3 to find the probability that a house had exactly 3 bedrooms and at least, so there's an and, at least 2 toilets. Yep. Above, interestingly, in 1 and 2, they asked us these 2 questions separately without the and. They asked us exactly 3 bedrooms, and they asked us for at least 2 toilets. So we can see that we've got a formula that looks like below. So what did they ask us on in number 3? In number 3, A3, they asked us to calculate the probability. This is in purple. This is the probability if a house has, so it's got 3 beds and then it had at least 2 toilets. Yeah. So they asked us to find that. Now in part 2, so let's have a look. Part 1, they asked us for exactly 3 beds. So that's the probability of 3 beds. 3 beds. And then in part 2 here, they asked us for the probability of at least 2 toilets. Probability at least 2 toilets. Okay, so can we see here that what we've got is everything that we need for that to do that probability check. So let's see if it's true. If they were independent, then that would be equals. Yeah, if they're not independent, then that will not be equal. So we can just carry out the calculations. So let's just check it out. So on the left-hand side here, we calculated just now that this probability of exactly 2 beds, 3 beds and at least 2 toilets was 0.92. And on this side, we calculated that the probability of 3 beds was 0.30, and we have separately calculated the probability of at least 2 toilets was 0.88. So if we multiply those together quickly, so we've got it to hand, here we go, let's just move that up to a place we can see. So the left hand side now, those 2 multiplied together is going to give us 0.2267. I'm going to do that to 3dp. How about that? Now, does that 0.267 equal the left-hand side, the and probability? No, it doesn't. These are not equal. 0.267 does not equal 0.292. So what can we conclude from this is that the above rule here, that they should be equal, is not followed here. So the conclusion, therefore, these two are not independent. So the number of bedrooms is not independent of the number of toilets. And of course we can reverse that. So let's just see what the word in the question was again. That the number of toilets is not independent of the number of bedrooms. Well, I've written it the other way round, excuse me, so I can write that way. Number of toilets. It's not independent of number of bedrooms, of number of bedrooms. There's sense to that, isn't there? There's common sense to that. Because the reality is, you wouldn't build a house with loads of bedrooms and have very few or no toilets, and vice versa. You wouldn't put loads of toilets in a house with no bedrooms. So it makes logical sense that those two are connected. So that's why I wanted to use this question, because I think that demonstrates key point that they could ask you to verify. Okay, here's a quick summary for you of what we've just gone through. So key point is if the outcome is randomly selected, the relative frequency will equal the probability. That's the first point. 2, there is no assumption in what we've just done that these events are independent. There is no assumption of that. So you need to test for that. If the question asks you, and you can check that by comparing probabilities using the rule below, the formula below. If the events are independent, then PA union with B, that's P and, that's an and, probability that A and B take place will equal the probability of A taking place times the probability of B taking place. Now, if that is not an equal, so if that's not equal, then they are not independent. Yeah, and that's as simple as that. It's an either or. It either equals and they're independent, or else it doesn't equal and they're not independent. And those are your two conclusions. I hope that's of use to you, and thank you for watching.